This PIERSON work-holding pallet system is one of my favorite tools for the CNC. And we have a whole bunch of pallets set up for this, and I've done other videos talking about how versatile it is. We even set up two 6-inch vices on one of these pallets together simultaneously, and it's all super rigid. This is the mini pallet system, so it's a smaller one, and it doesn't have the gasket underneath that the large pallet system does. If you look closely under here, you can see a gap, and you can see air through the gap. So there's a small gap under there, and there's no seal, there's no gasket around it. The larger pallet system comes with a gasket around it to keep junk from going under there. Now you think that, oh, this pallet is a lot larger than the base and nothing's going to get under there, but no, stuff gets builds up under there and gets crammed under there. Lots of chips and coolant and then oil, and it gets nasty under there. So that's why I ended up 3D printing this gasket out of TPU to prevent stuff from building up under there. So check out the top edge of this gasket. It's a dual seal modeled after a quad seal O-ring. So there's an outer seal and then there's an inner seal. And yes, if something gets through the outer seal, it could end up trapped in the inner seal. If like coolant gets in there, it's not going to leak out. I could have some coolant drain holes to drain coolant out of the outer seal. But I'm going to see how this works, and hey, if something gets trapped in there, then we can just blow it out afterwards. So this top seal edge has to be very flexible to accommodate the compression from the pallet coming down onto the base. So I've just cleaned this base recently, so it's pretty clean right now, but ooh-wee, let me tell you, it was filthy. After some of the jobs we did where the coolant and the chips just came underneath and filled this space up underneath with junk. There's still a lot of trapped junk in the grooves and the screw heads. So I designed this gasket so that it could just slip over easily on top of this. And I was planning that a slight stretch of the gasket would allow it to be tight enough, and it looks like it's good. The only place I see that could be an issue is on these long sides where it could bow out and be pressed out. But I have a little bit of a flat at the top, as much as I could design in there to sit on the top of the base. Now the pallet sits a little bit high until you release the air pressure, and then the balls really pull it down against the surface. So it doesn't affect the rigidity of the pallet once it's clamped down. It just sits a little bit high. This pallet is heavier like the one with the vise. If you push the pallet down with your hands a little bit, it's not going to go down quite as much. Here you can see the pallet being pulled down against the seal. Goes down, and the seal works really well to seal off the area. The gasket is getting pushed out a bit on the long front edge. It still seems to be sealing just fine. On the back, it's not as bad. It's better on the back. Something I could do to alleviate that is to 3D print a rigid plastic piece that goes around and clamps the TPU part, the gasket, and clamps it to the base, kind of like if you put a hose clamp around it to keep it from bowing out here in the front. So it just needs to be a little bit more rigid in the front, but not in the gasket sealing area, which it still seems to be getting a good seal. One more thing which I'm going to add, which I already have a feature under here to allow it to be glued onto, is a cover for the air connection and the pipe coming out to probably about right here to cover this whole area to keep chips from getting in there, because chips and coolant and stuff are all in this connector area, and they like to mess up these push-to-connect fittings. Currently I have 2 layers of heat shrink tubing, but what happens is this heat shrink tubing kind of expands over time, it gets loose and then chips and stuff get in there. So a hood is going to work better. Okay, so this piece that just finished 3D printing out of TPU it's going to fit right into the gasket piece and clips over this air tube. It's a perfect fit. Ultimately, I'm going to glue it right in here. I use some rubberized super glue to hold that in there. But that actually works just like that too. So overall, I'm quite happy with how this gasket turned out. There are still some minor improvements that could be made, like how to keep the long, straight edge from bowing out, which, like I said, my solution was to have a rigid clamp that goes around it. That would work. And if I do make a rigid clamp to go all the way around it, then I could also make the seal longer and more flexible. But for right now, it works without those modifications, so I'm just going to use it until we see that there's something wrong and then fix it. If you have one of these PIERSON workholding mini pallet systems, and you also want to print your own gasket to keep junk out, then check down in the description for the links to where to download those files and print your own. I'm also going to go into more details about how to easily print this TPU material on your 3D printer. Let me show you the settings that I use for printing TPU 95A on the Elegoo Neptune 4 Pro. These settings are specific to this add-on part, which is going to cover the air tube and air entrance into the PIERSON workholding pallet base. So the layer height is set to 0.12 millimeters. This could be increased to 0.2 or so. The wall thickness is set to 3. I just wanted a solid infill, and one of the ways to do a solid infill is just to increase the wall thickness until the wall thickness is so thick that it's thicker than your wall. The top and bottom thickness and stuff I don't really mess with. Infill density, I set that to 99%. Why 99% instead of 100%? Well, when you set it to 100%, things get weird sometimes. So 99% generally works better for a solid infill. And it also usually improves the surface layer appearance too. Now we're getting into some of the most important settings, which is the print temperature. All these have been set to 230 C. That was working well. The build plate temperature, dropped it down to 40 C. TPU doesn't need a hot build plate. In fact, bed adhesion works better with a colder build plate. The flow, I set it to 105%, so this just over extrudes a tiny bit. Doesn't leave any cosmetic defects on the outside, it just makes the layers bond together better. The initial layer flow of 125%, that really helps with bonding to the build plate. And in my case, it doesn't cause any squish out. Print speed is very important with TPU. So this printer can actually print faster than my previous printer. So the print speed here I have set to 60, infill speed 60, outer wall 60, inner wall 60. You can actually print faster than this, but this guarantees good results. The travel speed, you want that to be pretty low too, because when the extruder moves away from a surface, you don't want it yanking it in any direction. The initial layer print speed, I set that really low to like 20. This is really good for bed adhesion. And the initial layer travel speed, again, had that set pretty low, 90 or lower. The number of slower layers, this is a good feature to prevent the extruder from knocking the piece off of the build plate. That slowly ramps the speed up from 20 to 60 millimeters per second in the span of 40 layers, or whatever you put in here as a number of slow layers. So that can help with some features where you don't have a lot of surface that's bonding to the build plate and you want it to be really slow for a while and then speed up later. The retraction distance, I just left this as default. It seems to work pretty well. So enable retraction, 2 millimeter retraction distance, 30 millimeters per second retraction. Avoid print parts when traveling. I like to do that. Avoid supports when traveling. Z-hop when retracted. Z-hop height, I increase that to 1 millimeter. So it would really move far away from it and not knock anything over as the extruder is passing over. Enable print cooling. I have that checked. Fan speed 100%. And I'm only using the extruder fans. I'm not using that big fan on the back of the Neptune 4 Pro. No build plate adhesion, no brim, because the brim can really help with adhesion to the build plate, but if you're getting good adhesion, you don't need a brim, and a brim is difficult to clean off of TPU. No support material, because support material is a pain to clean off the TPU, so I usually try to design a TPU part to not have support material. Or if I do need support material, I use a dual extrusion printer that can support water-soluble filament. And finally, let's just take a look through the layers of this part from the top down. So it's solid, 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 solid all the way down, and then it spreads out and the base is solid too. So I'm going to use a spatula to help remove it from the build plate, because flexing the build plate is not going to work for this. So I can use a spatula to really get under the part. So as you could see there, this was very well adhered to the build plate. And it took a few tries to get it that well adhered. And the main issue was that the initial Z distance for the nozzle from the build plate was off. And it was too high and it just wouldn't get good adhesion. And I was also moving too fast. So the two things I did was I made sure that the initial Z height was set every time I tried to start a print. And I also slowed down the initial layer a lot. Slowed it down all the way down to like 10 millimeters per second to really get good adhesion on the first layer. Here you can see how little surface area was attached to the bed, and not only that, it started going off at an angle immediately. So this was a very challenging print to both get adhered to the bed and print without knocking it off or bending it while it was printing. And you can see that the end result is perfect. Everything came out super nice, super impressed. So the normal way to increase bed adhesion is to print a brim at the bottom. And I couldn't print a brim with this part of the bottom because this is a gasket and I didn't want to have to damage this sealing surface by removing a brim. So that wasn't an option.